better.
I don't know exactly. Well, I actually know what
Caleb,
both of them was. So.
You should get the second haircut.
The Dibola.
Okay. We are going to talk about the alternating series test, and what I'm going to do is I'm just going to go ahead and have you write it down, and once you have it written down, then we can discuss all of those symbols and words up there.
There's a lot of
Okay, we
symbols.
got 11 slides.
Technically, all of which are just a combination of symbols that have been commonly accepted as language.
What's this called?
I'm not sure what you said. I didn't listen, I'm sorry.
That's fair. I wouldn't have listened to that.
It's not that I was ignoring you. I was focusing and you were talking and then it was fast.
No, like I said, I completely understand. I wouldn't have listened either.
Yeah.
Also, if you're coming to Math Club, don't forget to bring food items with you. And then barcode. You grab something at lunch, or if you eat something, you can bring a wrapper. It doesn't have to be. I might do some recycle digging to have some barcodes.
What are the barcodes for?
In Math Club, we're going to talk about the checksum on the bottom of the barcode.
What's that? Is that the number?
The numbers at the bottom.
What about them?
I guess we could
They're special.
Why are they special?
Because they add to something, right?
You can come to Math Club and find out.
Just like credit cards.
Yeah,
But I'm not a math club member.
We could all
I don't
pull
know
out
if
our
I'd be
credit cards and do.
allowed to do that.
Just remember, guys, give me your credit card information.
Those 3 fancy numbers on that line.
Wait, so like the number doesn't matter what they add up to?
It does matter what they add up to.
That way you know it's
That's why
marked.
the very last number is specific to a certain algorithm.
Okay, very interesting. You gotta tell me
Okay,
about that.
so our alternating series test. We know if we have an alternating series if we have a -1 to an n, -1 to the n plus 1, -1 to the n minus 1. You can have a few different -1 to a power, n or n plus 1 is going to give you your alternating piece. So notice how I've written these two as there's an alternating piece times a sub n, an alternating piece times a sub n. So the alternating series test says that if we have an alternating series, if the limit towards infinity of a sub n, so take out the alternating piece, if that limit is 0, which, I mean, we kind of think about anyway, and what does this mean? Okay, non-increasing or decreasing, okay, then our series converges. Okay, so you need to show me 2 things when you have an alternating series. You need to show me that the limit is 0, which is something that we're mentally thinking about anyway for the nth term test. If it does have a limit of 0, then you need to show me that it's decreasing. Now, are we limited to a derivative?
What's the plural of series?
Series.
CRI.
Are we limited to the derivative to show that we have a decreasing sequence?
Smart. You could just write down a bunch of terms.
Nope.
No? Okay.
You plug in n plus 1 for n. So it's
And look
less
at the
difference.
or the ratio. We had the difference, the ratio, and the derivative test that we looked at way back when we talked about sequences that were decreasing. Okay? What's going to be the easiest to do? The derivative. But there are times where the derivative is not going to be feasible for us, especially when there is a factorial. Okay? We haven't talked about the derivative of a factorial, and we won't.
Wait, isn't there an integral definition of a factorial though?
Well, that doesn't help us further.
Integral definition and just get an expression.
Okay,
Oh
so
my god, slide 10.
I don't know. It's a factorial.
I looked it up, it's factorial.
Write this down.
Writing it down, man.
And we got like 10
This is
We don't. We have less than 10 examples.
There's 10 slides left.
Yeah.
This is the only
Two
rule.
of them don't contain an example.
Whoa, that's crazy.
examples.
Eight.
N plus 1 over. Hey, that goes to 0.
Maybe they include 2 examples, so then we have 12.
All right. This right here tells us that it's an alternating series.
Yeah.
Yes?
Yeah.
C.
Limit.
Since it's alternating, we can, number 1, take the limit as n approaches infinity of everything attached to the alternating piece. So what's attached to the alternating piece? 1 over n. And what is the limit as n approaches infinity of 1 over n?
Yeah,
Okay, we're good to go there.
sure are.
Now we need to show that this is a decreasing a sub n. Okay, so I'll remind you that a sub n is 1 over n.
You gotta take the derivative of that.
Derivative sounds lovely. The derivative would be negative 1 over n squared. And guess what? That is always
Decreasing.
negative. So we have a decreasing sequence. So this converges because of the alternating series test. Less work than yesterday, right?
And how do you
Because of those two things. As long as the limit of a sub n is 0 and a sub n is decreasing, since it's alternating, we know it's going to converge.
American Society of Transplantation. That's how I'm gonna remember it.
Is anybody else bothered that 1 over n was our sequence and it converges?
Like, it diverges.
But since it's alternating, we meet these specifications and it is a converging sequence.
So what's it converge to?
We don't know.
Matthew,
Hmm? Okay, but I won't ask you to find that. Natural log of 2.
is he right?
It's in the book.
You ready to?
It's an example.
Yeah, you
I don't
gotta
know.
believe
I've never
100%
opened
of
it.
everything you read, guys.
Especially in mathematics.
Hey, this is one of those alternating series things.
In your math notes?
Yeah.
That's so impressive.
Whoa.
Had to win in pool.
Okay, is this an alternating series?
Sure.
I'd have to concur.
Yes.
Okay, let's say it with confidence. We have negative 1 to the n power.
Yeah, I see. Yeah, it's all.
Okay, it's alternating. Which means we need to check 2 things for the alternating series test. What would a sub n be in this case?
1 over root n.
Okay, whatever is attached to the alternating piece, take off the alternating piece, that's our a sub n.
Okay.
So the limit as n approaches infinity of a sub n is,
That's 0. Check mark.
so that's good.
It's a pretty good check mark.
Let's go.
This is another case where I think the derivative would be a wise way for us to determine if we have a decreasing a sub n.
What's another way?
We just talked about the 2 other ways.
We did?
Yep, about
Difference
3
in
minutes
ratio.
ago.
Okay.
Yep.
Difference in ratio.
So n to the negative 1/2 gives us negative 1 over 2 n to the 3.
Yeah, that's what I got.
Yeah.
Which is always less than 0. So we, in fact, have a decreasing a sub n. So this converges.
That's great. If you just at the piece here, you like knockdown. Like you got that alternating stuff going. So
Okay.
Yeah.
Now we're going to cycle back to that issue here in a moment. that if the alternating piece was not there, this would be a divergent series, right?
Yep.
We will cycle back to that. But before we do,
Hey, bicycle.
we better
Another
talk about an example
example.
with a factorial in it.
Factorials are cool. They're like an explanation point, like n but excited.
And then drew 3 lines for like 4. Good.
I had a class that did not say factorial. They would say that that is the series of -1 to the n over n.
Why?
I like this to be neat. It's exciting.
Well, like instead of saying factorial, they
Oh,
would
they
just
so
like
louder.
N.
as like exclamation marks.
Wait, so if it was like,
Funny.
if it was the
Very funny.
n,
It was funny for like a day.
if it was like n plus 1, would they yell n plus 1 the entire thing?
Okay. A sub 1 would be just the 1 over n factorial, right? That alternating piece goes away. That's all we have left over. The limit as n approaches infinity of 1 over n factorial. Well, our denominator is giant. And towards infinity, it's just going to get more giant. So are we all okay of this limit being 0?
Big shot 0, yeah.
Check.
Okay. Now, the derivative is not going to help us determine if a sub n is decreasing or not. So I would suggest using either the difference or the ratio test. Do you have a
I
preference?
say ratio.
Okay. In this case, ratio would probably be our best bet.
Yeah.
Okay. So in the ratio test, I want you to compare a sub n plus 1 divided by a sub n. And we are hoping that that is going to be less than 1 if this is indeed a decreasing sequence. So a sub n would be 1 over n plus 1 factorial. A sub n would be 1 over n factorial. So we have n factorial over n plus 1 factorial. Okay. So we can simplify this, right? This is n plus 1 times n times blah, 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 blah.
What?
So we have n factorial over n
Yeah.
plus 1
Yeah, times n.
times n factorial, right?
So it's 1 over n plus 1.
Which will always be less than 1. So this is a decreasing sequence.
Check mark. AST. Okay.
So far, so good?
So good so far.
Any questions on the 3 converging series that we've looked at so far?
Ooh.
Just write it down.
Let's see what you did there. Is there going to be more notes or is it just more examples?
Just more notes.
Okay. Since I keep my notes.
I'm
It's
just
like
so
going by the
sad.
slide count.
I'm so satisfied that you already watched the video.
Are you going to be one day ahead for the rest of the semester now?
We'll see.
What would our first term be? Cosine of n pi. What's the cosine of 1 pi?
-1.
What's the cosine of 2 pi?
1.
3 pi? 4 pi?
1.
You see what's happening?
Yeah, it's going back and forth.
So what we really have is the sum from n equals 1 to infinity of -1 to the n.
Whoa, we just say it converges. Does it converge?
Would we? Well, we better do the alternating series test. Richard, since you asked, what would be our a sub n in this case?
1. Sorry.
Wow, Richard can really throw his voice to that side of the room. Do you agree? Is it 1? Okay. What's the limit as n approaches infinity of 1?
1.
Mhm.
1.
So
So
it
he-
diverges.
How? I don't understand how it doesn't converge to 0.
Oscillation.
Yeah. Say that again?
I don't understand why it doesn't converge to 0.
Oscillation.
So
What's that thing?
either my sum is 0, -1, or 0 or -1, and as we go through our infinite sum, it's just flipping back and forth to being equal to 0 or -1.
Yeah.
We're not actually adding numbers that gets closer and closer and closer and closer to a value, which would mean it'd be converging to that value. We're just boom, boom. We're just hopping back and forth. Okay. And we can just use the nth term test because the nth term test is taking the limit towards infinity of the sequence,
Yeah.
right?
So
If you said alternating series test, I'm not going to count that wrong, but you could also say the nth term test. Okay? Now, I want to go back to the fact that we said this converged. If that alternating piece was not on there, would 1 over n converge as a series?
no, B series.
It wouldn't, okay? So we can describe our alternating series as either absolutely convergent or conditionally convergent, based on if the alternating piece is not there, would it still converge or not? Write it down and I'll say that again.
So you have to do it twice, pretty much. You have to find if it converges twice.
Yeah.
So absolutely is if a sub n converges and a sub n converges when it's alternating.
So basically, you take away the alternating piece and it's still a converging series, then it's absolutely convergent because,
1 over n squared.
yes. Conditionally convergent means it's only converging because it's alternating. Without the alternating piece, not so much. So that example that I just pointed out, our very first example, that would be a conditionally convergent alternating series because without the alternating piece, it's the harmonic series, which we know is bad news. Not bad news, it's just divergent.
Alternation, that's not a word.
It's a good movie.
Alternation.
Yeah.
With,
I watched with my mom.
what is his name?
That was a good idea to watch that movie with me when I was in like kindergarten, and then she freaked out because I think they were like smoking and drinking with their coach or something.
But, what's that actor's name? He was married to Angelina Jolie for a long time.
Brad?
Before that.
I'll look it up.
No, it's not necessary right now.
That's
Okay.
alright. I can do it.
Example number 1. I mean, not example number 1, but example number 1 of this section. Example number 5. Is that what we're on, Zane?
Billy Bob.
Yeah.
There it is.
Billy Bob.
You want just the basic name,
Billy Bob.
and John Smith is taken.
It's alternating.
Yeah.
So we need to think about the sequence outside of the alternating piece. Okay. First, it's important for us to determine if this is just convergent or not. So, number one, does the limit as n approaches infinity of a sub n equal 0? Cool. And if we were to determine if this were decreasing, I don't know, I would say we can use the derivative, don't you think? Okay, we would have -2 over n plus 1 the quantity cubed, which is always less than 0, so we are decreasing. Okay, so right now we can say that this converges by the alternating series test, but what we now need to determine is does it converge absolutely or conditionally? Do you have a question?
I have a suggestion.
As to what?
Determine absolutely or conditional.
Okay, keep that in your brain for just a moment. We need to determine if the series 1 over n plus 1 the quantity squared converges or not. So just think for a moment about how, don't say it out loud, how you would want to go about proving it or showing that this is convergent or divergent. Just think about it. Turn to your neighbor and tell them your idea.
And have it 1 over the chapstick test.
In P series.
Yeah, that's the chapstick test.
Boys back here, what's your idea? LCT?
Yeah.
Up here? Direct, you guys said LCT? What did you say?
I was starting with
Okay, one of the comparison
Yeah.
tests is on your mind.
We said chapstick test. Just direct.
What would we want to compare to? Would you say?
1 over n squared.
Yes, 1 over n squared. Okay. Which is a converging P series. Okay. We know 1 over n squared. This denominator is obviously bigger, yes?
Yeah.
Which means the fraction is obviously smaller.
Yeah.
Which is what we want, right?
Yeah. Cool.
So this
Converges.
converges by the
Absolutely.
direct comparison test. So we can come up here and we can write this converges absolutely.
Is that built in to the AC or AST?
It's basically like doing two problems to answer the question.
Okay.
Did that answer your?
So what our final
Okay.
answer would be converges absolutely AST.
Okay, so your final answer would be converges absolutely. And you would have alternating series test, and I would also see that this converges by the direct comparison test.
So circle both.
Like, converges absolutely, alternating series test would be the most important, but then off to the side, I better see this. Do that. Okay? And only do the absolutely versus conditionally if they ask for it. If they are just asking for converging versus diverging, you could stop up here at the alternating series test. But if they ask you if it converges absolutely, then you would need to go that step further. Now, is this what we had earlier?
What we had earlier was just add, not add
No.
one.
Oh, in the numerator, I'm with you.
Are we trying to see if it's absolute or not? This one.
Yes, we will. Okay, so this is one of those problems where our brain can almost work faster than our hands to write it all down. Okay. We've already gone through the motions of a sub n being 1 over radical n, right? We did that earlier, and we talked about how the limit as n approaches infinity of 1 over radical n was indeed 0, and this was always 0, so it was a decreasing sequence.
Yeah. So it converges.
So we know it converges because of the alternating series test. But if we change it to a non-alternating series, so we just have the series of a sub n,
Does not be huge.
we know that this is a divergent p series.
So it's a condition.
I don't need you. So this converges.
Okay, it was nice spending time with you.
I don't think the program robot can be smart.
I don't think that was smart. I think it'd be nice.
Unless you program it to be smart, you know.
You
I
can get,
told her.
if you get
I-
Samuel L. Jackson on your Alexa, it's pretty smart.
Like I said, if it's
Oh, you can do
programmed-
that?
Yeah.
Yeah, it costs like $2.
It's 99 cents. It's
No.
totally worth it.
Okay. The alternating series converges. Without the alternating piece, it's a divergent p series, which means it converges conditionally. Okay. So the last thing we're going to talk about is
3 more slides.
the remainder. Okay. Now, when we talk about the infinite sum versus the partial sum, the partial sum, the more numbers we get, the more accurate it's going to be to the infinite sum, but it's not going to be exactly the infinite sum. See what I mean? Okay. So we are going to talk about the potential error we could have from the actual sum to the partial sum. Okay. So I'm going to have you write something down, and I know that it's not going to make complete sense right now, but I'd rather you write and then we talk. So write, and then I'll talk.
What's the S?
The S without a subscript is the actual sum, so the infinite sum. S sub n would be the nth partial sum.
Why do you think capital N instead of lowercase?
I don't know.
So it's okay for writing
You can write them.
okay.
Okay.
Rather than-
So the difference in the infinite sum and the nth partial sum is what we would call a remainder, right? That remainder will always be less than or equal to a sub n plus 1. Well, that's just a term. Okay, so your remainder is less than or equal to the next term in the sequence. Okay. For example, write this one down. And I tricked you because slide 11 just has your.
Oh, let's go.
That was a blade one.
And you know what? I'm gonna change this to a 6 instead of a 5. In the interest of time, I'm going to ask that you trust me.
5, 6, 7.
But do you know how to put a partial sum into your calculator?
What is it?
Okay. Now I ask that you not do this with me right now because we're a little bit close to the bell here. But if I wanted to bring up a summation, where would I go?
Alpha F2.
It's at the bottom. I don't know, go down. Summation.
Doesn't alpha F2?
Okay.
Yeah.
So you would probably use x
Equals
1 to
Infinity.
6
6.
of
Oh, so you just put
Type
6
it in.
on.
Where's the factorial?
under math, probability,
Oh my goodness.
number 4. Okay.
Wait,
Please try alpha F2 real quick. I was told that works, but I don't know.
No.
It's fine.
Okay. So if I want to approximate the sum using the 6th partial sum.
Yep.
We want the 6th partial sum. So if we were to type in the 6th partial sum of this guy, we would get 0.63194. Okay.
And that's just terms 1 through 6.
That's terms 1 through
added
6.
together.
Mm-hmm. Now, so that's the 6th partial sum. Okay. Our next term would be a sub 7.
Yep.
And that term is 0.0002. 1 over 7 factorial. Okay. So what this is saying is that our actual infinite sum would be in between 0.63194 plus that next term and 0.63194 minus that next term.
That would do it.
Okay, so we actually have a pretty good idea as to what the sum is. I mean, to a couple decimal places, right? We know that the actual sum will fall in between this range because the error is less than or equal to the next term in the sequence. The difference from partial sum to actual sum is less than or equal to the next term in the sequence.
So this is assuming it converges, right?
Didn't we already say that? We already know that this converges.
Well, I know, but that
But
was
yes,
part
it
of
would
the
need to
rule.
converge in order for this to be true. Yes.
So to do that, would you test convergence first?
Testing convergence would be good, yeah. And they might tell you, here is a converging alternating series. And
And then
that would
just
save you
have
some
to
time.
follow by-
But you would need